What is up? Daniel here with the Virtual Robotics Studio, and this time we are not in the studio, we are on a field. And we're lucky enough to be hosted by Team 302, and they have a full field setup. There may be some pillars that we have to dodge, but we've got basically the entire scoring grid built here, and they've also got an official Andymark field border that we can drive around with the robot. So it's going to be nice because you're going to get a chance to see what it'll look like when the robot is on a full-size field. We'll also kind of go back into the driver station where your drivers are going to be and get a look at what that view is going to look like as well. It's a lot different driving from the driver station, trying to drive the robot at you to score, as opposed to kind of being off on the side where you maybe have a better perspective on stuff. Anyway, on the field today, we have to do three things. The first thing is we're going to retune the robot. So we have those turnbuckles that we can adjust. We have the length of our rope stops. And we have the amount of surgical tubing that we're going to put on it. We're just going to make sure that everything is still going to the right heights, and it looks like it's going to work. Then we're going to drive around for a little bit in Teleop mode. We're going to see if the ballast weights that we added are keeping the robot from tipping over, and see how that works, see if we can score in Teleop. And then we have all of our autonomous modes that we tested kind of to the marks that we put on the carpet in the other room. But now we can test them on the field. We have the lines that we have to get across for the mobility points here. So we'll be able to do a full test and see if our auto modes are working. But before we do any of that, a special thanks to Argosy and Everybot. All right, the first thing we're going to do is let's see if it actually can get in position to score the cubes and the cones. So we did our measurement trick to try to put the end of the arm at the right height. Now we actually get to see if it works on this field. And don't forget, when you go to your first event, even if you do a practice field at somebody else's shop, the fields at the event have a plus or minus quarter-inch tolerance on everything. So you got to check again. You got to check every time you go out to a new field, whether it's working or not. So let's extend the arm out, and maybe we'll move over towards the cube spot here, the shelf. And let's see if we put a cube in. Kind of look and make sure the arm, as it swings out, we want to make sure it doesn't, hit anything. Also, the position that I think we're looking for, too, is there are these kind of beams that are down here on the bottom. And I think the proper position is pulled right up against that with the bumper. Another reason why putting the bumpers on before doing this test was important. So if this extends out, we can try to spit the cube out. That looks like it's in a pretty good spot. And we know it's going to spit it out faster, so we'll see if that's a problem or not. But positioning looks good. Let's move over and see how the cone looks. Okay, and I'll start with the cone inside. So when this is fully extended, it looks like it's going to have no problem scoring the cone. But there's something else we have to check, and that is the cone may hit this pipe on the way if the cone is sitting too low. So if the cone is all the way in, when it swings out, we are clearing. But if the cone is falling down, like I think it was in our auto mode, it may get stuck on the way, and now it's definitely too low to score. So we'll have to test that in our auto mode and see if we have to add, like I said, we might have to add something that says suck the cone back up before we lift the arm. All right, that looks good. And then let's spin it around. We have a makeshift loading station over here. So we'll see if that is in the right spot. And I don't want to go all the way across the field, so here it is at about half field. You can do anything you want to approximate the shelf. It should be 3 feet 1 3/8 inches to the carpet, and ours is pretty close to that. So if we swing the arm out in this direction, what we want to see here is, I think we want to have this roller contacting the top of the cone, because if it's touching the top of the cone, that's going to start pulling it in and sucking it in. But right now, it looks like we are a little bit too tall. And we can fix that we have multiple ways, right? We could shorten our stops. That's going to lower us down just a little bit to where it's catching. So let's do that first. And we lower those stops. Those are the Dynama cable ropes, and that is our badge clip turnbuckle here on the inside. So I'm just going to give that turnbuckle maybe 2 full turns, and let's pull this up and see where we are. Nope, let's keep going. It's possible I'm spinning this the wrong way. In case you were wondering, I was not spinning it the wrong way. All right, let's keep going. So we may need to really pull this down a lot. And we also have our cable that we can adjust too if we need to. And that looks just about right, because if it hits there, I think that's going to pull it up and in. All right, so unfortunately for me, that is all the way tight on the turnbuckle. So I would probably want to actually shorten this cable, tie it a little bit tighter, and then keep going. But we just barely made it, I think, where we are. So we will go with that. Also, you can loosen this turnbuckle, and that will also lower the arm down a little bit. Okay, but I think we're going to leave that just a little bit tighter. We'll see. Actually, it's a little high. All right, let's go ahead and retie the rope. So I'm going to do it on this side because there's less excess here. And first, though, I am going to set this turnbuckle back towards the middle, maybe slightly too open. And, all right, and you might want to put a little mark on here with a Sharpie just so that you know where the old knot was, right? We need to just make this a little bit tighter so we have a little bit more range in our turnbuckle. Okay, so that's where it was. I want to tighten it now so it's somewhere around here because I still have the turnbuckle that can go in or out. And I'm going to use the same knot. So over, under, and pull. Let's see if we got ourselves any lower. All right, that looks close enough. So make sure that's tight. And now we can tighten the turnbuckle to bring it down until it's touching the top of the cone. OK, that looks perfect to me. For intake, let's spin around. Let's go back to the goal and make sure we can still reach the goal. All right, sticking the cone in here. Okay, and then we're going to extend out. And it is still right there to spit the cone on. So I think this is now tuned correctly. Our next step then is let's power it up and try driving it around. All right, so we are back now in the driver's station. So you'll have a laptop back here. You'll have your controls, your gamepads back here. And you get this nice polycarbonate wall to protect you from the robots that are going to be playing the game. And first step is on the laptop, we are going to go ahead and run our driver station software and say yes. And that's going to pop up. We're also going to get our smart dashboard. All right. Our autonomous chooser is not there yet. So let's go ahead and go back to the gear. And we're going to switch to remote. And then switch back to Smart Dashboard. There it is. Now we can choose our auto mode. That's what we want to see. OK, then also, if you see, my joysticks right now are red, which is an issue. So let's go down to the USB tab here. And actually, if you just hit rescan, they should show up because they are plugged in. And remember, you can hit a button on one of the gamepads to try to figure out which gamepad it is. That's really weird that they're both blinking. So I'm going to unplug them, and I'm going to plug them back in, and we're going to try again. All right, so I'll plug one in and rescan. OK, so that one is not showing up. Let's try this one. So that one's working. Let's move that to be 0 here. Plug the other one in now. There we go. All right, so we have 1 and 0. So 0 is the drive base. 1 is the arm. And you know what? Let's just test stuff out. So I'm going to enable. And I have joystick 0, so I should be able to drive the base of the robot. So forward and backwards looks good. And then let's try turning. Well, I think this battery might have seen better days. So we might have to swap the battery, but for right now, we can kind of test a little bit. One thing we wanted to see, right, was now that we have the ballast on, how easy is this robot to tip over? So let's go ahead and go fast and stop. So before we put the ballast on, that would have tipped the robot over. Even if I go the other direction as hard as I can, it's kind of glued to the ground, so that ballast is doing its job. Now, let's go ahead and drive over towards the cone here. All right, and we're going to extend out. And then we're going to try to pick up a cone, which I think is this button. And if I drive in, okay, wait, that might have been the wrong button. Let me put the cone back. So remember, we have one button that is, yeah, that's very much, that was cube, not cone. So let's try that again. You can tell by the way the rollers are spinning after you stop, right? Because we have that little bit to try to hold it in place. So let's see, is that the right one? It was so long ago. All right. So Y is to intake a cone. All right, so I'm going to hold down the intake button and once again drive forward slowly. And we got it. So the next step would be when you're driving, right? We're not going to drive across the field with the arm all out like this. So after we have the cone, next step is to retract the arm all the way. And then while crossing the field, at some point, we're going to have to do a 360. And then we can drive up here. And let's see, that looks pretty lined up. Let's go ahead and extend the arm out. And I can see, because I'm right here, that that is very close to going on, but maybe not quite. A little bit of a turn. And let's go ahead and spit it out. All right, then we can drop the arm immediately while backing up, and we're ready to go again. Let's put a cube on the loading station this time, and we'll see how well we can score the cube. And I'm pretty sure the cube does everything easier than the cone. I think intake is better. I think scoring is easier. So let's give it a try. So again, while crossing the field, right, your driver should be ready to back up. At some point when there's space, you got to do that 180 to be facing the right direction. And then as we get close to the loading station, now, of course, remember, the loading station is going to be all the way on the other side of the field. I didn't want to walk that far to set stuff up today, so we're kind of in a shortened position. But we'll extend this out. Then we're going to hit the cube in button, which for me is A. And then we'll drive forward into it. And we've got the cube. Looks like there's a little bit of an issue. So let me see here. If I keep going, can I make the cube fall out? I cannot. So that is still stuck in there. As long as we can spit that back out, it's still OK. All right, so we'll retract the arm. And this time, we're going to make our turn. But we have to be over on the cube spot here. And when you approach, with this kind of robot, when you approach where you want to score, don't turn early like you would with a car. Get all the way so I'm straight lined up with it. It's right in front of the shelf. Then when I turn, I'm going to end up pointing right at it, because the turn is in place, right? Then from here, we'll extend out while driving in the rest of the way and make a small adjustment to be aiming at the shelf itself. And then let's spit it out. OK, so that is stuck. So that's something we want to look at. Looks like it got past the plastic there. So let's put it back in. And I guess we'll do it again. And we'll see. What we might have to do is adjust our plastic piece to be in the right spot. But just because it messed up once doesn't mean it's going to mess up every time. OK, tuck the arm in, cross the field. Arm out, intake the cube. OK, that time it looks perfect. All right, so arm back in. You always want the arm in when we're crossing the field, because there will be other robots, and if you hit the other robots, that's not good. All right, and we can get close to position here. Extend the arm out, and let's spit it out. Perfect. So it does spit it out pretty hard, but it looks like it is staying on the spot. OK. Then, just to do some testing, let's see if we can put a cube not in the top shelf, but let's aim for the mid shelf next and see if we can score there. Now, there's no stop on the arm for that position. So there are a few different ways that we can go about doing this. The first way is we can try to put the arm in a different position, right? Because we can control the arm and not be all the way out or all the way in, although it doesn't really like to hold those other positions very well. So first, let's grab it. OK. Looks like we got it. I like it with the button slightly early that time, so that's probably on me. But we can tuck it up, and it is holding on. So that's something to keep in mind. Make sure you hold the button until it is intaked all the way. And this time, instead of going all the way forward, I'm going to come back off the edge a little bit. And to me, that looks lined up when we spit it down. Now, we're going to be spitting from higher up because the arm is fully extended. Let's see what happens, though. So that is doable. The other option, right, would have been, and I'm just going to go ahead and put the cube back in. I'm going to help it back in. Oh, by the way, don't step over the rails on the side of the field. I think we talked about that in the rules one. All right, so the cube is back in. This time, though, what I'm going to do is I'm going to lower the arm a little bit and then drive back up so we're right next to it again. Right, so in this position, see, we'll turn a little bit, maybe go a little bit lower. That looks pretty good. So we can also try to adjust to this position and then spit it out, and that works as well. So it looks like it bounced a little bit, but also our intake was sort of blocking it to keep it trapped there. And then let's try one more. So we'll go back to intaking a cube. I'm going to help this cube in. And let's see if we can put it on the ground. And I don't really know where the best position to do this is, so we're just going to experiment and see if we can find something that works. So this position definitely will not work. We could try to do it from very far away. That seems like it's probably not going to stay there, though. So let's try to lower the arm down a little bit. And a little bit more. And maybe there. Let's try it here. One more down. That looks good. So let's spit the cube out. OK, and it looks like that is not actually scoring. I think it has to be all the way in, but probably just driving forward is going to score that on the bottom. So there are, let me go ahead and disable the robot while I walk out there again. So there are a few different things that you can do with the cube that's not immediately obvious, right? So you're going to have to spend some time as a driver practicing. This works best on the high position because it's all the way out when the arm hits its stop. This position is pretty easy, right? If you drive up, you can just tap the arm up a few times until it looks good and it looks like it stays there. Then the bottom one maybe is the hardest, but the nice part about the bottom one is if it's anywhere close, you can just push it the rest of the way in. All right, the next question, though, is what about the other cube positions or the other cone positions? So I don't know. This middle position is probably going to be the hardest one to line this robot up for. And then the ground one, we can probably do the same way we did the cube on the ground, which is sort of drop it close and then push it in if we need to. So let's go ahead and re-enable, and we'll intake a few more cones, and we'll see what we can do. All right, so I hit the intake cone button, and then I'm just going to help it in because it's going to hit the current limit. It's not going to keep going, but we know when you intake it correctly, it sucks it in a lot. All right, and then let's go ahead and move the robot over and see if we can put it on the middle row. So again, it looks like you're going to have to kind of control the arm up to the right position. And this is going to be very hard to do because it's always a little bit too high above the post. So it's kind of hard to aim. If we back up, I don't think that helps too much, right? And if we try to do it all the way extended, that's just a complete guess. So I think the only way to do the middle position is to kind of like pull up tight. And then you can just sort of adjust the arm to where it wants to go. Now, the nice part is just the way this arm works, it seems like it kind of likes to rock into a position that gives you a chance. So I don't know. Let's try it. This looks like it might go. OK, no problem. We'll back up. And let's go ahead and try the cone on the ground. right, so what happens if we bring the arm, what happens if we bring the arm all the way in? Like if we drop it here, can we drop it here? We can't. It gets stuck on the bar. But if we just go out a tiny bit on the arm and then spit it out, okay, that's pretty good. I think that actually counts. So there's something else that I saw there that I think you definitely want to be careful of, and that is if the cone ends up getting stuck like this, that might be the end of your match because you can't carry more than one game piece, and that would be stuck on the robot. Also, if a cone gets stuck inside here, that would be pretty bad as well. So something you might want to add to your Everybot if you have time is you could take some thin polycarbonate, thinner than this maybe, although you have this sheet. You could maybe do some kind of cover that comes up in here. So if a cone tries to fall in there, it doesn't have room, it falls out. Or maybe you can build up a back wall here. Maybe you could build up walls on the sides and the front in order to protect it. Now the front is a little tricky though because you can't go above this bar, right, that cross brace, or the cone won't fit in. All right, but that's looking good. So we can score high very easily because that's the stopped position. And then it looks like the other two you can do. You're just going to take more time having to adjust the arm into the right position, which is another reason why we're always saying the sooner you get this robot finished, the more time you can spend driving and practicing with it, the better you're going to do at the event. So we have definitely tested it now. We've calibrated it to this field. We've tested it, and we've proven that we can score high very easily and in the other two spots if we need to. So that is our calibration done. That is our teleoperated driving done. We tested our ballast. That was good. Next step, we're going to set up for auto mode. OK, so we're going to now set up and test our different autonomous modes. And the first one is easy to test because it does nothing. We probably don't need to test that one. Let's test the one where we just drive backwards. And I think we had it set so that if you were against the goal, it should back up enough to cross the short line. And I think actually the short line would be on that side of the scoring grid when the grid is all the way over, but it doesn't really matter for what we're doing. Let's just make sure it backs up far enough. All right, so that's set. Looks like a good starting spot. And once again, over here on the computer, we have to, on our smart dashboard, choose move only. That is the auto mode that we're going to run here. And then on the driver station, we have to switch to autonomous mode. And then we will enable it. OK, a little short. So let's fix that while we're here. So you can see I don't know, we need to go another foot and a half. So let's go into our code, open up WPI Lib, open your code back up. And if we scroll down, remember, everything is set in our constants up here. So our move only time was not long enough at 2.5 seconds. Let's make it, I don't know, 3.1. Let's try 3.1. And that's really the only change we have to make, right? Because it just has to drive for longer. So once again, 3 dots, let's build. And then once this finishes, we'll deploy it, and then we will run it again. And this could be because I didn't measure out the distances correctly in the other room. This could also be because some of the dimensions here are slightly different. But that's why auto mode, just like when we constrain the robot, we change the different stops on the robot, you're going to have to tune that to every field you go to. So if you get to an event and you do a practice match and your robot doesn't back up far enough, guess what? You got to make it back up more. So these are always going to be changing. All right, let's do deploy robot code. And any second now. All right. So we're going to be ready to go. Let's get the driver station back up. We're still on move only. We're ready to go in autonomous, but I do have to reset the robot's position. I guess I could have done that while waiting for the build and deploy. Okay, and again, make sure you're starting in exactly the same place, pointing in exactly the same direction for auto mode. Let's do this. 3, 2, 1, go. Go? There it is. Perfect. So that's well clear of the line that we were aiming for, and we don't have to worry about any issues there. Okay. And again, there's no reason to try to get like an inch past the line, because then if something goes wrong and you drive a little bit slower or whatever, you put a slightly deader battery in, you don't cross the line, you don't get any points. All right, we're going to disable the robot. Let's reset it. Next one we're going to test is our cube auto. So we'll get the cube here. I guess I can just kind of shove that in now. Looks good. And then let's bring this over to the cube shelf. And I think this one, we want to back up past the longer line. But we'll start right up against it. Make sure you're aimed good. And one of the things you can do is there's no rule that says I can't, bring the arm out. And obviously, you would want to do this before you turn it on, because now that it's dynamic braking, it's kind of fighting me. But before you turn your robot on, if you bring the arm out, you'll know, okay, that looks pretty good lined up on that goal. So now we will slowly push it back in because brake mode is on. And remember, at the start of a match, everything on your robot has to be inside the frame perimeter, which is sort of the area that the bumpers are going around. So we have to make sure we're tucked all the way in. That looks good. Let's head back to the computer. And looking at the smart dashboard here, I'm going to choose Cube and Mobility. Okay, then on the driver station, make sure you're on Autonomous, and let's test it. 3, 2, 1, go. Arm out, spits the cube out, arm in, backs up. And we want to go to the longer line, so this one should go a little bit farther. Oh, is that over the line or not? That is, I don't know. That's too close for comfort is what that is. So we're going to drive a little bit farther back. The other thing we can see now that we're out on the big field here is the center of the field is way, way, way over here. So this is the line that we can't cross in auto mode. We have so much space left to go that, if we back up another, even if we go another like 2 feet, we still have plenty of margin for error. So let's go ahead and increase that back up, and then we'll test this one more time. That looks like it is back where it was. We'll load the cube in here. And we're going to jump back into WPI Lab, into our code. And what is the constant that we have to change for this? Remember, move-only time is how long we drive when we're just moving. Auto drive time is how long we're going to drive after scoring a cube or a cone. So it's this number that has to get a little bit bigger. Right now it's 385. Let's go to 4.2. 4.3. Let's try 4.3. I don't know. You can try whatever number you want. I'm just trying to make an educated guess, and then, of course, we're going to run the robot and find out if it was correct or not. So build your code. And then we're going to deploy it. All right, pop up that driver station. Make sure we're on cube and mobility. We are. Autonomous. Let's try it again and see if we go far enough this time in 3, 2, 1. Okay. Some things happened. I think that's definitely a good distance, a good driving distance. If I kind of bring the line over, we're solid 1.5 feet past the line. But our cube fell out. So we need to figure out why that happened. and we have a few options to try. We can change the speed at which we spit the cube out. We don't necessarily have to go full power when we release the cube. Another thing, too, is it might be that loading the cube in here in different directions is going to make it work a little bit better or a little bit worse. So put this back in. And a general rule of thumb for any autonomous mode is just because you run it and it works once, that doesn't mean you have a working auto mode. That means it worked once. You have to run it several times in a row, and it should work every time. So let's try it again and see what happens. OK, so we're not going to change anything. We're going to do cube and mobility, select cube and mobility, and autonomous, and let's just run it again. OK, that looked good. So let's just do it again. We're going to try to find out if the cube bouncing out was really, really unlucky or is something that happens a lot of the time. OK. Cube and mobility, autonomous mode. Let's do it. All right. So based on that, I'm starting to think that maybe my aim was slightly off the first time, or we just got a very unlucky bounce. But let's go ahead and do it one more time. OK, looks good. All right, still cube and mobility. We're just going to run it again without any changes. Here we go. That looks pretty good. So at this point, I'm starting to believe the first time that we ran this and there was a problem, I think it's possible that maybe it looks like putting it in flat is nice because it sort of hits and doesn't do anything. But I think that first time, maybe it hit the side, and that caused it to bounce out. Or it came down right on the point, which makes it bounce a little bit more. I think. Let's see. Yeah, maybe not. Maybe you want to hit the point. Looks like it bounces a little bit more when you don't hit the point. So you could maybe use that in terms of how you load the cube for your first one at the beginning. But it looks like, I mean, we've had it fall off once. We did it several times in Teleop, and we did it several times in autonomous mode. So I would not make a code change right now, but just know that if your cube is hitting and bouncing and going all over the place, instead of spitting it out with full power, I think we use 1.0 for our whatever intake speed when we're releasing the cube in the cone. You could reduce that down. You could try 0.9 or 0.95, 0.87, whatever, until you find one that works. All right, so I'd say cone auto is good. It's in the bag. Let's do our cube auto is in the bag. Let's do our cone auto now. All right, line that up. And let's take a cone. And we'll load the cone up here. And you can see no matter how much I try to push it up, it starts falling back down. I wonder what if we kind of bend the cone around a little bit? Does that help it stay? No, that makes it worse. OK. Good to know. Yep, so it looks like as we wait for the match to start, it is going to sink down a little bit. So the question is, did it sink down enough that it's going to hit, or is it going to work? Well, only one way to find out. Let us go back to the computer. We're going to switch our auto mode now. So on our smart dashboard here, we are going to choose cone and mobility. And then autonomous mode, oh, it's still enabled. OK, let's disable it. And then when we re-enable it, we will see if it hits or not. All right, let's find out. All right, disabled it. So technically, that was a successful auto mode. It just wasn't the kind of successful auto mode that we wanted. All right, so the cone is still in there. It's still scored. But what happened when we tried to release it, right, is when the arm swung up, first it hit here, and then it was so low down in the gripper that it sort of swung forward, hit like this, and then we released it, and it fell down to the bottom. Incidentally, though, we learned something. So sometimes it's good when you do things like this. If you need to score a cone in Teleop on the bottom, it seems like the best thing to do is to just intentionally miss and let it roll down the ramp and hit your bumper. So instead of aiming so that it's on the pole, just miss to the side. And that seems very, very repeatable. All right, but we have a problem, and we're going to have to fix some code. So this cone, we need to suck it up into the gripper more, into the intake more, before we swing out and try to score it on the post here. So let's take a look at our code. We have to be a little careful, though, right, because our code right now does the same thing for both cube and cone auto. So we're going to have to find out which one it is and what we're doing with it. Or maybe we'll split them apart. So back on the computer, back looking in the code, we're going to scroll down until we find our autonomous mode. So we are looking for autonomous. There it is. So this is cone and cube. But we don't want this to be cone and cube. So cube is good, but cone needs some extra stuff. So this entire else case here, let's go ahead and say, let's change it instead to an else if. Right? And just like before, up here, right, we say m auto selected is whatever. We're going to now check to see if m underscore auto selected equals, right, because we're checking, not setting a value. When you want to check the value, use the double equals. And we'll say this one is k cube. Cube is here, cube is done. Cube works. All right, we can actually take all of this again. And this is what we're looking for. We're going to start with the same thing, right? So we'll also change this note here as well. So this is now cube auto mobility, and then cube/mobility. Sorry, cube/mobility auto. And we can also leave ourselves a note here that no longer the same as cone, because we need to intake the cone more. All right, then if we start at this else if, where it's else if k cube auto, we're going to just select that line, and we're going to go down and 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 down until we get to this curly brace here. So we have kind of 3 curly braces in a row. That's the one we need. You can tell if you go next to this one, right, that one is highlighted. So we're going to select all of that. We're going to copy it. And then we're going to paste it in here. So now we have this k cube and then a second k cube down here. Let's change this one to k cone. And let's change our note here to this is the cone auto, which will intake the cone at the start. And we have 2 different ways that we can try to fix this. We can intake the cone immediately and then raise the arm, or we can just turn the intake on while the arm is being raised. And I think it's simpler to turn the intake on while the arm is being raised. And the arm is only going up for 1.1 seconds before we would spit the cone out. So I think we can just have the arm on that whole time. We do have the current limit. I think it's going to be OK. So in this very first section here, where we do elapsed time is less than arm extend time, right? That's the 1.1 seconds, right? If you hover over this, it tells you 1.1 seconds. So that's the 1.1 seconds it takes for the arm to extend out. What we can do is instead of having our intake motor at 0, let's set our intake motor to, let's see, intake output power. And the one thing we have to check, though, is we have to check and see if this output power should be positive or negative for intaking a cone. So if we scroll down to, sorry, scroll up to, no, scroll down. Let's go to Teleop and see which button is which. So in Teleop, on the intake, if you press button 1, that's the cube, and that sets our intake power to positive. And if you do button 4, that's the cone in, and that sets our input power to negative. So we have to make our input power negative here. So I'm back up in auto mode where we were changing this. We have intake output power, but it should be negative intake output power. And that should suck the cone up into the arm while the arm is extending out. Now, of course, we can't do this for the cube too, because if we left this version in for the cube, that direction is to spit the cube out. And if we had gone and checked the direction based on whether or not it was cone or cube auto, that would work. But actually, I don't think we want to try to intake the cube more once it's all the way in. We saw that one time when it came in funny, it got stuck on the plastic. And by the way, if that keeps happening to you, we have a whole 4x8 sheet of that plastic that we used on the intake. Go ahead and cut yourself a wider strip and reattach it so it's a little bit further forward and a little bit further back. All right, I think this should hopefully solve our problem. So let's hit the 3 dots and let's build. Then we'll deploy it, and we will see if it has enough time to suck the cube up, or suck the cone up before the arm gets out to a scary position. If it doesn't, we'll actually have to add one more step to our auto mode, which is intake the cone first. All right, let's deploy it. All right, looks good. So now we're going to go to our auto mode, make sure it is cone and mobility, select autonomous mode. All right, and then we're going to give it a try here in a couple seconds. 3, 2, 1, let's go. So that one, if you saw right at the beginning, sucked the cone up a little bit, and it was just high enough for it to be able to clear that first pull. Let's bring the robot back. We got to try it again. One time never proves anything. And let's try the worst case scenario, which maybe is going to end up being the best case scenario this time. We're going to find out. So we're going to put this cone in. And the worst place that it could be potentially is if it falls all the way down, right, and it's resting on that crossbeam member. That's as low as it can go at the start. So that's where we're going to start. And we will see how that does. So no code change. Just make sure you're still on cone and mobility and autonomous. And we're just going to run it again and see what happens. And what I want you to do when you're running this is watch the cone at the beginning, right? See if the cone sucks up high enough, because that is our one change. So that's what we need to be looking for. All right, let's do it. 3, 2, 1. All right, so it did, right? Right at the beginning, it sucked the cone up. It actually didn't suck the cone up as far as I think we would have liked. But that could just be that because the cone started in the robot, our intake motor might only be so powerful. So I think, let me put the robot in position here. I think when we go, for example, over to the loading station to intake a cone, the intake is already spinning at full speed. So it has a lot of momentum to grab and suck the cone up in really far. But when the cone starts in it, it doesn't have any of that extra momentum, so it has to sort of force and crush the cone as it goes. And so that's why it's trying to suck it up, but it can't quite go far enough. But the good news is it's going far enough to be able to score every time. Now, the other thing I'm going to check here is we're going to run it one more time, but I'm going to kind of check this motor, our Neo 550 that's on the intake, because we are sucking this up and stalling it for that whole 1.1 seconds while we were deploying. Well, probably about half of it. It probably sucks it up for the first third of a second. And so we want to make sure that that's not putting any undue strain on the motor. I don't feel any warmth. We do have the current limit anyway that's kind of backing up as a safety there. So one more time, we're going to put the cone in, and we're going to try it. And I'll just let it sit right on that beam for the start. OK, we're going to aim. Make sure we're aimed at the pole. Looks good. And we're going to run it again. And if this one works, that will be 3 times in a row without changing the code. So then if something works 3 times in a row, I'm starting to believe it. I would probably still run it a few more times, but I'm always scared of auto modes not working. All right, we're on autonomous, we're on cone and mobility. Let's do this. All right, that looked perfect. So we tested everything we needed to test, and it all worked. Teleop, we're able to drive around, we're able to score. Everything's looking good there. By the way, for Teleop, right, if it's not on the axes you want on the joysticks, because it might read in differently depending on what kind of joystick you have, just know, right, you look at that driver station, find out which axes you want to control it, switch to that. Mine was working exactly the way I wanted. Forward and backwards on the left stick, left and right on the right stick. We did the tuning. Don't forget that tuning is going to be a big deal. Every time you go to a new field, you're going to have to extend this out all the way. Make sure the tip of the cone is right here on the bottom edge of the wheels. So it's touching. Maybe you go up a little bit on the wheel, a 1/4 of an inch or so, maybe 1/2 an inch on the wheel. That's going to help to suck the cone in. And to adjust that, right, you got the turnbuckle. If you have to, if it's too far out, you'll just have to retie the rope and then use the turnbuckle to fine tune it. You've got the second turnbuckle here on the steel cable. So if the arm is out far enough, but it's not tipped back enough, you can tighten this. Tightening this will bring the arm back up a little bit, or if it's too high, you can loosen this, and it'll drop down a little bit. But you can see we've got a little bit of a bow in this one. The other thing that you need to be watching for is when this goes all the way back, and it hits that stop all the way back, make sure this front edge is beyond the bumpers here. Right? So we're inside the frame perimeter. That's where it has to be legal when you are starting a match. Also, we talked about this while you're driving. Anytime you're crossing the field, make sure this arm is in. If this arm is out, there are lots of problems. The first problem is the robot is very tippy. It's much more unstable this way. But the second problem is when there are other robots on the field, if this thing is out, like whatever, 40 inches, 48 inches out from the front of the robot, and another robot crashes into it, first of all, it could be a penalty. If you are the one moving and hitting the other robot, that's a penalty. But also, this is not something we want taking huge hits, especially from the side. The way it's designed, if it gets hit from the front, it sort of folds up and protects itself. But if it gets hit from the side, it will break eventually. So when you're crossing the field and there's potentially defense, tuck it up, be nice and safe and compact. And then once you get into the safe zone, the community zone or the loading zone, and you're starting to line up, then go ahead and extend it out. The other thing that we didn't talk about is if your arm is not staying up in this closed position, and if it's really not staying out, like if it comes down a little bit when it's out, that's okay because the motor will push on it a little bit and break. But if it's not staying in or out at all, either tighten your surgical tubing bands or add another band. That's okay, right? And what you want with the surgical tubing bands is it should be tight enough to kind of hold it out and not much tighter. So it should just be in this area where it's just barely enough to kind of put it there. I would probably want mine a little tiny bit tighter. So it's just barely holding it out there. Because any more surgical tubing that you put on, the motor has to overcome that to actually make it move. So keep an eye on that as well. All right, and then remember the lessons we learned about how to score on the different levels with the cones and the cubes. Spend time driving, spend time practicing that. The better you are at that, the better the robot's going to perform. I've seen lots of like middle-of-the-road robots do very well at competitions because they were driven well. If you can get the most out of your robot, that's going to be probably the single biggest thing that can improve your performance at a tournament. All right, the auto modes worked. We talked about how to tune those. If you're not driving far enough, make a change. We made the change to suck the cube in more, or the cone in more. And we talked about slowing it down if necessary to get the cube to stay on the shelf. So you have all of those levers that you can tweak. If you have other auto modes that you want to write, like if you want to try to write going for the balance on the charge station, go for it, right? Just do another else if, add another K auto in all those places, and you can have a completely different auto mode going. But that is it. This is a completed robot. We've run it. We've tested it. It is working quite well. So I am excited for you to take this thing to the competition. And for the last time, Daniel here with the Virtual Robotics Studio. This is it. We have made it to the end of the robot. We finished all of the videos we have planned for this Everybot series. And it works, and that's pretty cool. We're pretty excited about that. But before we go, we did want to take a minute to thank everybody who helped us make this possible properly. So first and foremost, we have to thank Argosy, whose support has basically made the entire project something that we could do. Also, we want to thank Bruce Stone and Medita, and all of Team 302 who have hosted us here and supported us throughout the process. Jack and Jay, who we sent down to the Everybot team to keep us apprised of what was going on so we could plan ahead and be ready to get these videos out as soon as possible. Of course, we want to thank the entire Everybot team for the robot design. You know, we need that to build a robot. For parts, RCO Engineering, Leon Pryor, also Rev Robotics, Andymark, and Thriftybot all went above and beyond to rush us our parts as soon as possible so that we could start building the robot. And finally, Cara Alpert for the set design. I'm a pretty big fan of this set. I had a lot of fun being here and building this robot. And we hope to be back in the future with many more educational robotics videos. So until then, so long.